1, 2, 3. Yeah, that's better. So anyway, my name is Alexander Rothacker. I'm running the Team Shada, which is a security research team for a company called Application Security. We are a database security company. That's all we do. It's like we do tools to help you protect your databases. And really why I do these talks is just, if you look at this famous tower here at the castle in Heidelberg, and they really did a great job, and they built really nice perimeter protection, and well, it cracked. You will always get there, no matter what you're doing. So if you look at recent data, last year, 27 million records stolen from databases. Or stolen in general. Over 90% of those came from databases. This is the usual reports. You've probably seen those, Verizon. And we really believe that, or I really believe that database security is not the focus yet of companies. And it is where you have your stuff, right? What kind of data are hackers after? They're after credit card information. They're after personal identifiable information. They're after your company's secrets. And as much as you protect your perimeter with firewalls and all these things, and they're good, I'm not saying don't have them. Once they're inside your network, they will get to your databases. And so make sure you protect them. And so things that we typically see that are used against databases are, well, there's SQL injection that comes through the website. There are password attacks. Access controls are not really very effectively set up on databases. There are Java exploits and just configuration issues in general. And I really think this is gonna be a theme for this year, and it's been a theme for the last couple of years. So we sort of have like a little top 10. It's a little bit. If you look at it, it's very similar to the OWASP top 10: logins, passwords, SQL injection, privilege issues, patch issues, buffer overflows. And I'm just going to go through a couple of them really quick, and I'll show you examples of how you actually attack a database, and then a little bit how you defend yourself against it. So logins and passwords. When you install your database, out of your default, you run your setup program or your scripts that do this. Databases will install a lot of default accounts, and so do applications that you put on top of the database. Like if you install an SAP or an Oracle e-business on a database, it will use a lot of default accounts. And quite often they have known passwords. So what we do is disable those accounts if you don't use them. Quite often they're just used for setup. And then change those passwords. If the account can't be disabled, change the passwords to strong passwords. Another thing is, these installations will write data quite often. They write passwords into log files. Try to find those passwords in your log files. Do a grep or a find after installation, basically on the whole directory that has your Oracle or your SQL Server installation. Try to find them. And sometimes you will, and then clean that up. Make sure those log files are gone. Otherwise, anybody else can see your passwords. Very standard practice: password expiration, reuse, strengths. Right? Make sure you configure that properly, and it's very different in different databases. If you're going through your OS, obviously you have other OS settings that you have in Windows or in different Unix versions. But databases often also have their own logins, especially in the Oracle case. There isn't really an easy setup for some of that. For example, password strengths or reuse, you have to set up, basically write your own little procedures and use triggers in Oracle to do things like that. Another thing is when you assign privileges to accounts, don't assign them directly to the account because it's going to become a nightmare to manage that. Assign them through roles and groups. And another thing is login activity is often not really traced. And that's really how you find an attack, is by, or one way to find an attack, or if people try to brute force passwords, is monitor your login activity. So you can either do that in your audit logs, you can set up triggers, you can use tools to do that. There's a couple examples here for default accounts, so pretty much everybody has them, right? And these are mostly older ones. We're not really shown 0 days here, but you know, Oracle Scott Password Tiger, that's a very famous account. Then you look at SAP, right? They have their default usernames and passwords. And one of my favorites that Oracle had, database security, not my problem. I mean, they have an account called DBSNMP, and that's the password for that account too. Now, let's talk a little bit about SQL injection in the database. So SQL injection in the database works very similar to the way it works through a web application. You create some SQL that you inject some code, and then it gets executed. There's slight difference. This is usually a flaw or a vulnerability in the database code itself. This is not your application code, your web application code on top of it. So I'm going to have a quick example here. Our target is SQL Server 2008. We do need a little bit of an elevated privilege here, create database, to do this. And after that, our attacker will be a NSA. So we create the attack user. It's called Hacker Harry. There's a nice password. And this is and we grant this one privilege that we need. So it is a little bit an elevated privileges, but users might get those from their admins every once in a while when they need to install software to it or other databases. So we look, and our attacker here, so he's trying to get usernames and passwords from the syslogins table, which is where SQL Server stores their user information. And okay, you see SA and you see yourself. And I want to, add myself to the sysadmin group, and it fails. I want to look at the AdventureWorks database, which is like a sample database that usually comes with SQL Server, and well, that fails. Now what we do is we create a database, and the funky thing here is if you look at the code, like at the name of my database, it's actual SQL code. So that's my SQL injection that I'm setting up. Now I back up the database regular to a file on disk, and it does all that just nice. I drop the database. So again here, this is basically the SQL, that's the name of my database, right? So this is execute sp add server role member to Hacker Harry. So I'm trying to make myself a sysadmin. Now I open that backup file, and in my hex editor, right? This is really cool stuff. I find my database name in here, and this is 1 byte here, 27, and I changed that to 7. And Microsoft did something really nice here, where they treat 7 specially. Now when you restore that database, and here you see the cast for ORX7, so that's basically that character again too. It actually restores it, but it also executes that SQL. So there's a SQL injection in that restore function. And well, look, I see a lot more usernames now because I'm an SA. And I look at my AdventureWorks database, and I can get to that too. So this is probably the only vulnerability that I'm aware of that was ever found in SQL Server 2008 and published. Microsoft doesn't even acknowledge it as a vulnerability. They say because you're elevating from a privileged account to a higher privileged account, it's not a vulnerability. I don't really know why, why then they have those different levels of privileges when it's not a vulnerability if you jump from one to another. But anyway, so here's another one. So this is in Sybase 15.7, ESD1. So again, this is fixed in the latest patch. In ESD2, they kind of fixed it, and then you changed a byte, and it worked again. So we're setting up an attack user here, and actually I have it set up already, this user. But you look at this user, his name's James, and he really doesn't have any roles. He's a very basic user. Now, is TempDB as my database because I'm trying to do a create table, and getting that privilege on TempDB is a lot easier than having it in general on the database. And so here, same thing sort of, right? You see my table name has some SQL code in it. And SQL code commits, the SA role and the SSO role to James. And I create an index, and again, I have that whole SQL code in there in the name because that's the name of the table that I'm creating the index on. And it does fail because, that's some really weird table name. But it did execute the SQL code. And I'm still James. And look, I'm an SA and an SSO. So this is, right? It's all mine. I love it. So how do we protect the database from attacks like this? It's a tough one. The flaw is in the database code. So you really, the only proper fix is you need to patch your database. And this is going to be my message throughout this. If you have a database, patch it, patch it, patch it. Don't wait a year. Like, probably, I don't know, half the organizations you're working for, they're patching every 6 months or less. Minimize the attack surface. The more features you have installed on your database, the more likely there is a vulnerable function in there or some code that's vulnerable. Limit your privileges is a really important thing. Just like anywhere else, the less privileges you have to execute things. If I didn't have that create table privilege in that last attack on TempDB, I couldn't execute it. Right? You can then monitor your database activity or look at your logs. Really make sure you have audit logs set up on your database. And be aware of what kind of vulnerabilities are out there on databases. This stuff gets published in Security Focus and other places. And if you are aware of particular functions that are vulnerable, go and search your audit logs for them being called. At least that way you can prevent the attack, but you can find it and react to it. User group privileges. Again, this is something that's very similar to what we have in IT all the time. And yeah, everybody, hey, it's great, right? Nobody should have more privileges than what they need to do their business functions. Really try to be aware of, what users can actually do and have good policies in your organization and make sure you audit your users' privileges on a regular basis and minimize, throw out users that are not in the organization anymore, things like that. Because users can gain access, right, by by roles that are granted to roles and all that stuff. This stuff isn't easy. And then another thing is after you install a database, default database privileges. Databases give a lot of privileges at install time usually because they want to make the customer use features. They want to make it easy for them. So what we're going to do here is we're going to, again, try to become a DBA, right? And anyone would create session, which in an Oracle database, that's everybody. And we're attacking an Oracle 11G R1. And this is an attack in Java. It was presented by David Litchfield about 2 years ago. One of the few things where Oracle actually jumped and released a patch right away. They didn't wait for a critical patch update. So, so here, let's just try. So we logged in, we're user 1, and we're seeing, you know, who can access all files through Java in Oracle. And nobody. And then we're trying to basically call bin touch on that temp Oracle file, and we can't do it, right? So we don't have the privileges for it. This is all good. This is the way it's supposed to be. And now let's try to see what we can do. So here's what we do. We create a Java virtual machine access control policy. And we're granting a lot of stuff. And here is the flaw in Oracle. They actually, in a default install, if you look at that import JVM perms, public has privileges on that. Everybody is part of public, right? So even though I didn't have, you know, I couldn't do all that stuff, I can just, everybody can grant themselves the privilege to do this. So after that, well, user 1 has, you know, can do Java stuff on all files. And I can execute my Java, basically, so now I can access my operating system. And I do my bin touch, and bang, see? I'm running OS commands through Java on that machine, even though I really had no privileges before. And those OS commands basically now run in the context of the Oracle user. So a pretty privileged account. Yeah, here's, right, there's my file that I created through the touch command. Nice thing is, the bad guys, it's not a lot of work for them to find these flaws. Right? Do a little Google, and here's your whole exploit. You know, you can even find a video on the Black Hat website where David Litchfield's shown the whole thing. So let's go through the best practices again. So how do you defend yourself against these things, or try to do as much as you can? Never grant permissions to a user directly. Always through roles and groups. Just makes it a lot easier to manage them. Keep the roles very specific. Don't cast your net too wide. Really think about, you know, what kind of different roles you need. Rather create a couple more roles and manage them appropriately. And audit those role memberships. I think that's a really important thing. To keep going through every 6 months or whatever, you know, does Joe really still need that admin access? Public privileges, and this is not just in Oracle, but other databases have the same problem. They grant a lot initially, and we see it a lot in, it's not an easy thing to do. So when we go and we tell people, you know, take those public privileges away or restrict them, sometimes databases break or certain functionality breaks, so it's not an easy thing to do. You really have to go and test your applications, make sure they're still working after you've done this. It takes time. It's a pretty hard problem to solve, and it's different for every organization. It's not something you're not go, you know, you just go and do it for everybody, and it works. All right, unnecessary enabled database features. So when you install your database, the vendors want to upsell you, of course, to everything they have, right? From their spatial to their little CRM application or other things, reporting that they sell with the database that they can upcharge you for. So make sure after you install, if you don't need a feature, get rid of it, because these features are exploitable usually. Java is a great one, right? Oracle comes with Java, Sybase comes with Java. And other databases have similar mechanisms to call OS commands or do advanced stuff. So in this case, we're attacking, again, a Sybase 15.7 on Windows. And pretty much, actually, you don't even need those two privileges. Was just a copy and paste on my slide there. So here's our user that we're creating. Here's a little DLL that we're creating. That's the DLL we want to call, but we could call anything else. This is just an example. So basically what it comes down to is when in this Java exploit, when you load the DLL, or we can load a DLL, right? And so if we write the DLL properly, it can execute anything. You know, it's not just who am I, but you could do other stuff in there too. Now you say, okay, I have to get that DLL on the system, but you can actually even call a remote path. So that way you don't even have to have it on that system. All right, so here we try to load the DLL, and well, doesn't work, which is good. Now, this is a little more advanced. It's using reflection in Java, and again, it's a flaw that Sybase had. Initially, it was a little easier to exploit. Then Sybase fixed it. Then we had to do this, and now they fixed that too. But yeah, basically, it's a bunch of Java classes, and because I do all this weird reflection code, I suddenly can call my select load ceval DLL, and it just does it. It worked fine. So minimize your attack surface, right? So in SQL Server, XP command shell is really a very common thing, and the recent versions don't enable it by default anymore, but all the versions used to have it. And still, if you go on the web and you look at like SQL Server forums, and one of the first things is like, you know, somebody asks, how can I execute OS commands from my SQL scripts? I really want that as a feature for my cool app that I'm writing in SQL. And everybody will answer, oh, just enable XP command shell and use it. Yeah, really. You just opened yourself up to a whole lot of pain. Basically, you're making hackers' lives super, super easy when you do that. And there's a bunch of other ones. OLEDB, ad hoc query, open row set is a function in SQL Server that lets you query other databases, and it kind of breaks security quite a bit. In DB2, it has a create not fence feature that usually when you fence things in DB2, you really put some layers in what people can do, and by enabling this feature, you make your app development a little easier, but you really hurt security. Another thing, add-on modules that come with databases. Oracle has the spatial feature, MD-sys. If you look for Oracle and vulnerabilities, you will probably see that 30% of those of SQL injections in Oracle go through MD-sys functions. If you don't use it, if you don't need spatial stuff, just kick it out, uninstall it. There's a new feature called Locator. That's sort of a subset. That's a lot more robust, and for most people that'll work. Java, as I just did the the exploit on Sybase, and Oracle has Java. It's a great tool for hackers to get in there and have fun. Oracle Enterprise Manager Grid Control that's a pretty cool tool if you want to administer your databases. It's a web app. It's full of SQL injection holes. So if you're using it, really make sure you patch it. Every time Oracle releases a CPU, go and patch that thing. SQL Server itself, Microsoft, has been really great security, but some of their add-on things like reporting, they're using UI DLLs that are part of the OS, and people find vulnerabilities in those all the time. So again, you don't need it, turn it off. Now, configuration management, when databases first came out, right, they were great. You install the little thing, you say, okay, here's my instance name, and here's where I put my data files, and that was it. Now we have so many features and add-on modules and security settings and whatnot. Really, really take the time when you install a database, or if you create basically like a template for your organization, what databases should look like. Go and look at, there are so many standards out there that tell you how to harden your databases and what configurations are good security configurations and which ones are not. Look around, find the ones that apply to your industry, you know, if it's PCI or if you're working for the government and you need like CIS kind of stuff, and well, this is the US government. Disastick is another one. There's some of them are very specific and they give very good detail on how to configure that and what to avoid, which pitfalls. And then when you create those configurations, try to create a baseline or a snapshot and compare that, like every, audit it and look at it every couple of months and make sure not some DBA went in there and was like, oh, I really want XP command shell. Bing, I enable it. What are, like, I don't know, typical stuff is in DB2 we can trust all accounts, all clients. Well, that means any DB2 client has full trust, even you have no idea where it's coming from. Or in Sybase, you think you configured auditing and you set it to delete the log file after, or the audit file, right, when it's full, or you only have 2. Well, if a hacker goes in and they want to exfiltrate your data, then in order to erase their tracks, all they have to do is write a lot of log entries that are innocuous, and they flush out the logs. Think about those things when you configure them. So here's another one. This was a fun attack that Oracle sort of released by accident. They released a critical patch update in, I think this was April last year, and they credited a researcher called Jackson Carrot, and they credited him as security in-depth contributor, which is somebody who made the product long-term better. And he kind of mistook that, and he was like, oh, they finally fixed that flaw that I reported it way back like 4 years ago. And he started tweeting about it and wrote a blog post and released the proof of concept code. And then Oracle came back and was like, oh, no, we didn't really fix that in this critical patch update. We just gave you credit because we're going to fix that in Oracle 12 or something. So anyway, how does this attack go? So in Oracle, you have your client, right? The little man there. You have the listener, and the client connects to the listener, and then the listener gives it an IP address and a port number and says, talk to this database. Now, in this TNS poison attack, you create a proxy, and because the listener kind of accepts all kind of requests, you just say, "Hey, I'm that Oracle database" to the listener, and from now on, that listener will redirect the traffic to you instead of straight to the database. Bang! You're in the middle. You can see what you want to do. You can get all the info. You can actually do commands on the database because the database doesn't know. It's not your client anymore. All right, so here's our target database on 0193. And we connect to it. And we make a connection to the target database. DBA might read some sensitive data. Right? So users get some password hashes. Now what we do is we write this little proxy in Python. And you can find this in Jackson's blog post. So you start that proxy with that IP address. And we register it. So basically we send a packet of data to that listener because the listener protocol is pretty well known. And the listener will then say, "Oh, here's my database. I'm going to send you traffic from now on." And so we connect to the database again. We do read our sensitive data. And this is basically what that little Python script saw. Right? So now it sees that unencrypted traffic between that client and that database. And so up there you see our name and our SQL that we called. And this here is the hash for the password. And this is an easy configuration fix. Really, all you have to do is you turn off dynamic registration on the listener, so that little Python script can't just go and say, "Hey, here, send me traffic." And then only allow secure connections, so you can't just look at that TCP traffic anymore. For rack clusters, what Oracle did is after they were like, "Oops, we made a mistake," they basically now give away a feature for free that enables SSL for listener authentication. This used to be an add-on feature that you had to pay for. So yeah, simple configuration changes sometimes might really help you fix your database, and that's stuff you need to be aware of. Yes, it was an add-on feature. You paid for whatever, some ridiculous Oracle price for it. Buffer overflows, again, this is very similar, all the same as it is in programs or operating systems. Simple buffer overflows, we can crash a server. Advanced buffer overflows, we can actually execute our own code. We want to fix this, we need a fix from the database vendor. There's really very little you can do to protect yourself any other way. You can, yes, I guess you could audit certain commands that are susceptible to buffer overflows, but by then your database is down already anyway. So in this case, it's a DB291 FixPack 8. It's a little bit older attack. But it's really simple and easy. It's so nice. So this is kind of small, but so we have our user one, connect to our database, and here's our SQL code. Select repeat 1, 1000, and then some huge number. So basically, we create this big loop within a loop from sysIBM sysdummy. And we run this. Don't really need any privileges for it. It's very simple as a SQL. Oops, DB2 service terminated. Right? So this is how easy it used to be to crash a DB2 database. Luckily, they fixed that one. Again, we look around on Google and we find that code right there, very first entry. Select repeat. Privilege escalation. of course, it's basically similar to what we've had before. Low privilege users becoming DBA is not the goal of pretty much any attack. Again, we need vendor fixes to fix those things, but at least if we go and we monitor our database traffic and we look at our audit logs, we can go and at least try to find out, if somebody's exploiting these things actively. Oracle 11g release 2, create a procedure and execute on mdsys reset in proc index, right? So there's one of those famous mdsys spatial issues. This one's a little harder. This is actually a fun attack to execute. So when you set this up, you create a procedure, and in that procedure you grant yourself the privileges you want, so your DBA privileges. Then you create a function that contains code to create a trigger in the system schema, and that trigger calls the procedure you created before myproc. To exploit the vulnerability, what you need to do is you need to cause mdsys to run that my function that creates the trigger. And then you basically you trigger the trigger using totally public privileges by running a SQL statement that causes that trigger to fire. And then that trigger calls myproc, and it does that with sysdba privileges or the mdsys privileges, which are equivalent, and it grants you DBA. So we create and replace, right? This is the procedure that we create, and that procedure says grant DBA to user 1. That's the fun part. That's what we want. And we grant execute to our proc to public because, well, we want everybody to be able to execute that one, right? Now, we create that function that creates the trigger. So if you look up here, execute immediate, create a replace trigger, system evil trigger, and that trigger is before an insert on system OL $. And we grant execute to public to that function to public. So to run the exploit, right? We're taking advantage, again, of a SQL injection in that reset in proc index. And so we do T, 3 quotes. So if you have like 3 single quotes, that's always kind of a hint that there might be some SQL injection going on. And so we're calling, right, or user1 my function. This is the exploit that causes mdsys to run the function to create the trigger. So now we have the trigger created. We're still not DBA. But now we insert into that system OL $ table, and that will trigger the trigger or fire the trigger, which will then call the function to grant me DBA. And sure enough, let's start from session roles. I'm a DBA now. Again, Google, our friend. I really like Google. So how do you protect yourself against these attacks typically? And you see this slide is basically the same one that I had before for a lot of other stuff. Right? There are weaknesses in the database, and these databases are complex, so there will be more of them. So whenever a vendor releases a patch, go and update your databases. Don't wait. Do it now. And I know it's expensive for the business. Businesses don't like to update their databases, and sometimes even your business application vendor might hold you back. SAP might say, "Well, we are certifying against Oracle 11g R2 with critical patch update from 2010, but we haven't really tried it on any newer ones." Minimize your attack surface. Like in this case, not having spatial, you couldn't execute this attack. Or also limit privileges. Like if you don't have a create procedure, you can't execute this attack. If you know about attacks, go look at your audit logs, see if those functions have been called anywhere or have, do activity monitoring on your databases. So not patching your database is probably one of the worst things you can do. If a vendor releases a patch, it takes the bad guys maybe a day or two to reverse engineer it and figure out what the vendor fixed. We do the same thing when we write our signatures to detect attacks. Oracle doesn't give out any information. We take the CPU and we reverse engineer it, and it's not that hard. I mean, it's basically a bunch of SQL code and scripts, and then we know what they fixed and what they changed. Now, what do you patch first? Of course, you patch your critical systems first, because that's where the juicy data is. At the same time, that's really hard to do because you don't want to interrupt your business processes, right? Now, in order to patch the database, you might have to take it offline. You have to maybe do some testing first because you don't want to apply a patch and then it breaks the database. Good thing with that, at least, is that the vendors have gotten a lot better in testing their patches, actually, and making sure that they don't break functionality. They really just fix the issues. But so even after you've done your critical systems, don't forget your low-risk systems. An unpatched SQL Server is a great way to break into your organization's network. Some of like the TJ Maxx attacks that Alberto Gonzalez did, he found some old abandoned SQL Server in the network, and he used XP Command Shell, and from there, this is how he executed all the stuff. And it was an old SQL Server that ran basically as a system privilege process. It was a great jumping in point for him. So yeah, even if you think, oh, this is an old database, I don't do anything with it anymore, turn it off if you don't do anything with it anymore, or patch it. Know what's vulnerable. Really, really know which databases you have in your organization. I think so many companies have no idea how many databases they have. They think about the couple big ones, the one behind my SAP and the one, this one and that. But how many SQL Server Express gets installed by so much software? It's just pretty much everywhere, and often enough, it's not very protected. And a skilled attacker can find that instance, even though it might have an obscure name, and exploit it. Last thing is the data in your database. If you can, try to encrypt it. It's sometimes a limitation, not everybody can do it. Encrypt your file system. Have the data not written in plain text, because otherwise somehow people get access to those data files and they can reverse engineer them. There are great tools out there now from third-party vendors or from the database vendors that let you do transparent data encryption. They can be on a column level, on a row level. There's a lot of neat stuff out there. Educate yourself, see what's available, and use it if it makes sense. And another thing is data in motion. So when your client connects to your database, so many clients by default use unencrypted protocols. Sybase, by default, no encryption. Passwords go clear text over the wire. So make sure you set those little options in your applications when they connect to the database. Use encryption, use SSL, or go over a VPN or anything like that. You can see on Team Shadow is like a website that we have. That's our research-only website, and we have some white papers there that really explain that stuff in more detail and how you can configure your databases accordingly. Scared yet? Well, don't be scared, or be scared, but do something. The worst thing you can do is simply not do anything. And that's really my big pet peeve, is that I think database security is just very, very underrepresented in this industry. Relying on perimeter protection, I don't think it really works, because the bad guys will be in your organization if they want to be in your organization, in your network. Sony was an Oracle attack. That's how they got the PlayStation network. They just cleaned out their Oracle databases. They had unpatched Oracle databases. Epsilon, similar. I mean, it's just yeah, like the Gonzalez attacks, right? They used the SQL Server. Now, who's responsible for database security in your organization? Do you know that? Are you aware of it? Is it just a function of the DBAs? Because the DBAs will not do security unless you really, really step on their toes. Security is a hassle for them. They don't like it. It makes their life a lot harder. So the data owners, I think, should be, with the CSOs or equivalent people. They should make sure that database security is a priority, and that you're really aware of what's going on your databases. So to end this, I just want to give a couple of credits here. These are the people that found all these exploits that I just demoed to you, right? David Litchfield, him and Alex Kornburst, they're really the really big names in Oracle security. Esteban Martinez Fallo, luckily he works for my team. He's found over 100 vulnerabilities in Oracle and reported to them that they have fixed. Martin Rachmanoff, great SQL Server security researcher, he found that issue in 2008, and he found a bunch of those Sybase things I just showed you. Evgeny Legorov had one of those Oracle exploits, and Jackson Carrot, he had that TNS poison attack. And there's a bunch of references if you look at the slides when you download them from the Troopers website. We have, there's a lot more information about it, more detail. Same for vulnerability disclosures. If you don't do this on a regular basis, not just for databases, but for other stuff, go to Security Focus. Go to the CVE website or the NVD website, and basically search for vulnerabilities against the products that you have in your organization, and be aware of what's out there, and what you need to patch, and how severe those issues are. That's it from me. Thank you so much. Question?